safety. Yeah, regarding safety, accidents in industry cannot be avoided. There is industry, there will be accident, but it can be minimized. How? From learning your past experiences. From learning through your past experiences. CSD, which is the from US, community, but in India, we don't have any such organization which will report the accidents, investigations, right? Why this is happening? What is the cause of that accident? How many people died? What is the root cause? Everything was mentioned in the CSD report, right? India is lacking that way. Another thing, right? So, keeping this into mind, what mistakes they did. If we have same plant, we should not repeat the same mistake in our plant. First thing. Second thing. In the there is a green project and there is a brownfield project and the greenfield project. Have you ever heard about this? No. Greenfield project is something which is not yet built, but it is in the conceptual stage, right? And brownfield project is something which is already established and you want to expand some of its unit, some of its production, or expansion. That is the brownfield project. Now, as a Gaxcon also, all been recommended as in conceptual phase itself, you need to perform the consequences analysis and QRA, quantitative risk analysis. Why? There is a 3D tool, CFD, right? Generally, in India, what Indian people does to get the, your industrial, any project or industry has to be from MOEFCC, right? To be, accepted. They do it not voluntary, but as a compulsory. That government has told you and you have to do it, that's all. But in European country or other countries, what happens? They do it by themselves. So the culture, safety culture has to be established. The mindset should be like that. How it will be? Should start from generation of your age. Mindset should change, right? Now, what is the consequences analysis? If I would say that if you had noticed in the previous case also, if any flammable gas, like ammonia is also, if the gas is flammable as well as toxic, so which analysis will you give preference to? Whether to the consequences analysis of flammable gas or the toxic gas? Which analysis will you give the preference to? The same gas could be flammable as well as could be toxic. Which consequences analysis will you give preference to? Which analysis? Toxic. Example, a very good example, well-known example, Bhopal gas tragedy. Yeah, if there is a flammable consequence and if flammable gas, and there is a congestion, defines the congestion, the explosion, level of explosion is defined by the level of congestion, right? How much level of congestion is there? All three-dimensional modeling is there and we do the analysis and everything, right? So there will be explosion, there will be flyaway and something like that. But in toxic dispersion, like Bhopal gas tragedy, innocent people will die because of the industry mistake. Gas may travel anywhere. It can move anywhere, right? Can move anywhere around Bhopal city, along the direction of the wind. People which are inhaling, innocent people all die. It was the worst ever tragedy happened. That onwards many changes has happened. Safety comes into picture, right? So that was all about this. Yeah, there are much spectrum of safety, like process safety management, PSM is there. One is LOPA, layer of protection. Yeah, LOPA analysis is there. So if this thing go wrong, level indicator goes wrong, then that thing goes wrong, this layer of protection is there. If this failure happens, then that. Right? Then there is a hazard study, hazard analysis. Yeah? So we do the department wise, each and every, all from department, each and every person, from engineering, from instrumentation, from procedure, plant wise. Yeah? All people are gathered, so together, and we divide into nodes of a plant. And then we analyze, if this happens, what will go wrong, what will go wrong. Then we define the LOC scenario, loss of containment scenarios. Out of these scenarios, we take them, major scenarios, into picture. In the design phase, conceptual phase itself, you can do this. Major scenarios has been taken from that, and then we bring it into the QRA report consequently. There is a lot of metrics and everything is there. It's another subject. 2 to 3 days of subject, right? Anyway, then what is there? If you are out of this LOC, loss of containment scenario, limited scenario, CFD scenario, because it takes days to happen. What you will consider if this particular gas will leak due to any what can be the reason? What could be the reason of leakage of the gases? What could be the reason possible? Come on.
Human error.
Yeah, but what?
Failure of valves.
Failure of valves is the major, and leakage. Corrosion. Pipe corrosion. Yeah, pipe corrosion, leakage from the walls. Yeah, you must have seen even the Bhopal gas leakage of the walls. There is a safety walls, safety slips down. Yeah, scrubbers not operating well, and hazards. There are the standards that how much hazard you can, combine, or you can have in your industries. All rules has to be taken care. Okay, then LOC scenario has to be taken, and then what is the consequences analysis then? That what will be the consequence if this particular leak happens due to any, and reason, how far it can go, then how will you decide? Then there is a factor, like there are many factors, means that particular concentration will die the people. Chlorine gas of 10 ppm. Yeah? It is hazardous. Yeah? Hazardous to life, there is a word. Yeah? So if this particular ppm, so we will analyze for that particular ppm, different ppm level. What will be the distance? Taking different wind direction into account. We take a combination of all these things. Wind directions, wind classes, Pascal classes, everything, right? Okay. Then that is the consequences analysis of the toxic or the flammable gas. How far? Now, as one of you told that for fire to occur, the fire triangle should be completed, right? So there is a source of ignition. What could be the source of ignition? What could be the source of
Sunlight.
Spark.
which spark? Electric spark. Other
Static charge.
static charge.
Very good.
Other, yeah, in explosive industries, even you have to be discharged, you know. Yeah, and other,
Vibrations. Vibrations.
yes, other.
Friction.
In flammable, if
Somebody
gas
said
leaks,
friction? Somebody said friction? Huh? It's a
Yes, sir.
major source of spark. Huh? So you have very high velocity liquids flowing and they can also generate big spark. So static charge and very good. Please, sorry, continue.
no, please. Thank you. There could be your motorbike, motorcycle, car, yeah, around people, yeah. There is an individual risk. There is a societal risk. You know, society. It's a lot big picture, right?